Hi students, let's see a very important topic of chemical bonding, orbital overlap concept. It is also known as valence bond theory, but a valence bond theory includes hybridization also, and today we'll not be discussing hybridization. I will cover it in my next video. So covalent bond, we know that is formed by sharing of electrons. So we'll be seeing some 4-5 cases of covalent bond formation or orbital overlap. First is the hydrogen molecule. We know that in hydrogen there is only one electron which resides in 1s orbital. So electron which is present in 1s orbital will do overlapping. This is an head-on overlapping and will form sigma bond. In case of fluorine molecule, if you write the electronic configuration, you will see that one unpaired electron is present in 2p orbital. So these 2p orbital will do head-on overlapping and will form sigma bond. This is very important point here, that this p should be pz if z is the internuclear axis, because only the orbital can collide on along the internuclear axis. Alright, so third case is HF. Here also we have hydrogen, electron of hydrogen is in 1s and electron of fluorine is in 2p, as we have seen in above two cases. So 1s will overlap with 2p and it will form a sigma bond which is between 1s and 2p. Right, this is again head-on overlapping and will give rise to a sigma bonding. Let's see another molecule, and in this this is oxygen. Here we'll see that there are two unpaired electrons present in p orbital. So one will do the head-on overlapping and will form sigma bond, and another will do the sideways overlapping and will form a pi bond. The sigma bonding orbital must be pz if z is the internuclear axis, and another one could be px or py. In case of nitrogen molecule, if you write the configuration, you will find there are three unpaired electrons in 2p orbitals. So again one will be in 2pz and other two will be in 2py and 2px respectively. So 2pz will form sigma bonding, and because they will overlap head on, and rest two will form a pi bonding because they will overlap sideways or lateral overlapping. So far we have seen that if there is overlapping which is SS, SPZ or PZ, then sigma bond will be formed, and if there is overlapping between PX, PY and PX and PY, it will pi bond will be formed because as a result of sideways or lateral overlapping. Right, so single bond, when there is only sigma bond, we call it a single bond. If it is a multiple bond, it means that there will be pi bond along with sigma bond. Right, pi bond can never be. So let's see some questions from NCERT. So C2H4 and C2H2, we have to find out the number of sigma and pi electron. Also we have to draw the diagram, but diagram I am not drawing because we haven't discussed hybridization. So you can see the number of sigma and pi electron here. I have written 5 sigma 1 pi and 3 sigma and 2 pi because there are 3, it's a triple bond. In case of question number 4.29, they are asking us to consider X as internuclear axis. So it means that now PX will form sigma bond and PY and PZ will form pi bond, because they will not be able to meet head on. They will only be meeting laterally. So you can see that in case of A and B, sigma bond will be formed, whereas in case of C, pi bond can be formed only. Next is 4.32 question, where they are saying distinguish between a sigma and pi bond. So sigma bond we have seen can be formed alone. It will be formed only when there is head-on overlapping, whereas in case of pi bond, sideways overlapping will be there. Sigma bond is a stronger bond, pi bond is a comparatively weaker bond. Sigma bond can be formed alone, whereas pi bond will never be formed alone. Right, next case is explain the formation of hydrogen molecule. We have already seen it above. So next, this question is from Exemplar. Here we have to calculate number of pi. So we can just draw the number of bond. Here NCERT hasn't shown this hydrogen. There will be this hydrogen which I have just drawn, you can see. So if you count all the single bonds, they are coming 19, and if you count the multiple bond or the double bond, so they are coming 5. So each double bond consists of 1 sigma and 1 pi. So that's it. Thank you. Good luck.